We'll conclude this section with a review problem. So we're asked to find the general solution to the differential equation 1 plus x squared times dy dx minus y equals 5. I will solve this equation in two different ways. Namely, first I'll solve it as a separable equation, and then I'll solve it as a linear equation. So if we solve it as a separable equation, let's write that down. Solve as a separable equation. What we get is that we can rewrite the equation as 1 plus x squared times dy dx equals y plus 5. Now, we want to bring all the y's to the left and all the x's to the right, and then have dy on the left and dx on the right. So what we get is that 1 over y plus 5 dy equals 1 over 1 plus x squared dx. So the next step then is to integrate both sides. And on the left, we get ln of the absolute value of y plus 5 equals arctan of x plus a constant of integration. So now we're going to exponentiate with respect to e on both sides to get rid of the ln. And so we get the absolute value of y plus 5 equals e to the power arctan of x plus c. And we can rewrite the right-hand side as e to the power c times e to the power arctan of x. And getting rid of the absolute values here means that we have to put a plus or minus in front of this constant, but that's still a constant. So we see that y plus 5 equals some other constant k times e to the power arctan of x. And then finally, we'll move that 5 to the other side, and we get our final answer, y equals k times e to the power arctan of x minus 5. That's our final solution, solving this equation as a separable equation. So now let's solve this as a linear equation. So I'm going to solve as a linear equation. So the first step is to write it in standard form, and we can do that by dividing by 1 plus x squared. So we get dy dx minus 1 over 1 plus x squared times y equals 5 over 1 plus x squared. So that means that p of x is negative 1 over 1 plus x squared. And our q of x is 5 over 1 plus x squared. Second step, we want to find the integrating factor, so that's e to the antiderivative of p of x. And so that's e to the power integral of negative 1 over 1 plus x squared dx. And the antiderivative of 1 over 1 plus x squared is the arctan, and we have that negative in front, so that's e to the power arctan of x, and we don't worry about a constant of integration. So the final step then is to solve y of x as 1 over mu of x times the integral of mu of x q of x dx plus a constant of integration. And what we get is 1 over e to the power negative arctan of x times the antiderivative of e to the power negative arctan of x times 5 over 1 plus x squared dx plus a constant of integration. Now, this integral looks kind of intimidating, so let's do that on the side. So let's take a look at what is e to the power negative arctan of x times 5 over 1 plus x squared. Now, the derivative of arctan is 1 plus x squared, so it seems like a u substitution would work here. And so let's try a u substitution. U equals arctan of x. In fact, let's do negative arctan of x. Then du dx equals negative 1 over 1 plus x squared. And so that means that du equals negative 1 over 1 plus x squared dx. And solving for dx, we get that negative 1 plus x squared du equals dx. Okay, so when we plug that into our differential equation, or into our integral, we get the integral of e to the power u, and then times 5 over 1 plus x squared, and our dx becomes times negative 1 times 1 plus x squared du. Now the 1 plus x squared cancels out, and we're then left with the integral of negative 5 e to the power u du. And the antiderivative of e to the power u is e to the power u, so we get negative 5 e to the power u. Okay, so we take that whole thing, right? That was a way to find what this integral was. So we can continue that as we can bring this to the numerator as e to the power arc tan of x, and then times the integral is actually negative 5e to the power u, so we can write that as negative 5e to the power, and u was negative arc tan, so negative arc tan of x, and then we had plus c. Okay, and now what we'll do is we'll distribute this over our two terms, and the e to the power plus arctan x and the e to the power negative arctan x, when you multiply those two, you add the exponents, you get 0, and so that's e to the power 0, so that's just negative 5. So we're then left with negative 5, right, for the first part, and then plus c times e to the power arc tan of x. And that is our final answer, and that's the same answer as what we found here. So y of x is that.